Alright, so today we'll do a real example on how to use a decision tree model, which is this, to actually predict a CSV file. But first, I will simply talk about what is decision tree. So basically, let's see if we have a data and we're trying to predict an outcome, such as if this patient have condition or not. We can look at all these data, and then the computer will use this model to find the best question to ask to separate the data into it's given what we want to predict. This is a really standardized tree diagram. We, we ask a question. If it's yes, we ask another one, and then we derive to the condition. I will not really talk about the math behind this model that deeply. It's basically simply speaking, just this function that can find the purity of a data set, and the computer need to test out uh like which question to ask so that the data can be separated most purely, which means the majority of let's say the yes condition will be on one side, and majority of the no condition will be on the other side. And what we will do is, so we need to predict whether uh the buyer will buy the car, if it's accepted and accepted, if it's good, very good, based on the price, the maintenance, how much doors it have, how much person it have, how big is the luggage, how good is the security, with these attributes. And we will prove, and we also there's another small homework, not really homework. I will review the answer at last, but after we build the model, we need to prove that how much doors this car have, does it impact if the buyer will accept the car. Alright, so first of all, I will show you guys what is it like. So this is a really standard heat diagram. The lighter the color, it's a higher the number. I will explain this more later, but basically this is what it will look like. And okay, and yeah, basically that's it. Let's get into the real program. So first of all, we from matplotlib import pyplot. This is a really important library for data visualization and etc. It will be used to draw that heat diagram, which is very easy to show the accuracy of this model. And we also need to import this pandas as PD. Pandas is probably one of the most well-known, if it's not the most, and most used library, data analysis library. It's really good at just dealing with all these data, all the CSVs and stuff like those. And then we will wait, what is actually, let me here. Yeah, I didn't really remember all the library because there's like so much library that in Python, and like the best way to do it, just search it up in Google, and then we'll this data equal to PD the read CSV. Basically, it gives this whole CSV, and we put it in a readable fashion for the computer. So this will be like basic it, and it will be converted into like zeros and ones, since that's how a computer like read it. But we do need to give in the link. So I think I will just share this drive like this data with you guys, and then just press this to download it, and then go to your file, and then go to download to see all the stuff, and then you can open it in VS Code, and then just like use the link. Press right key to press on copy link. And now what we need to do is like we need to convert. This thing is so unclear. We need to convert all the class into numbers, such as 0, 1, 2, 3. So the computer, it will be easy for the computer to predict it, and the computer do need like numbers, which means we also need to convert these into number. But let's do this first. Data is called class. So basically that will make I iterate through this whole column, since this column is called class. And I will become these attributes, so we can like modify all these like variables in the column. And if I equal to unaccepted, I will equal to 0. I'll leave I equal to accepted, and I will equal to 1. I'll leave I equal to very good. Actually, it's just good. Then I will equal to 2. Else, which is that if I equal to very good, I will equal to 3. Right now, if like we print if we just print out the data, which is basically the CSV, why is it still like that? Let me print out the class. It should be. It should not be like this. It should be like numbers. Is it because I just printed it? Like it didn't really modify the CSV itself. But that's alright. So let's continue. Now, after we changed, though it said that we like didn't really, it's still unaccepted. Wait, why it's I think I think we already changed it, but just that it will not show it since it's like just from the data point. So now we need to change these into numbers, and this is actually a bit harder. Since if we want to change it into numbers this, now we cannot just do 0, 1, 2, 3. I mean, technically we can, but what we always like usually do in these type of scenarios is we change it to decimals. So if there's like 3 attribute, we will change it to 0, 1/2, and 2/2, which is basically 1. If there's 3, we'll do it 0, 1/2, and then if there's 4, we'll do it as 0, 1/3, 2/3, and 3/3. Like the reason why we do this, so like if it's like this, v high will equal to 0, high will equal to like 1/3, for example. So we do this so that the data will not be really spread apart. So if we have a really gigantic data set where each number is like huge and very separated from each other, it'll be really hard for the computer. Not really like any model, but just for this decision tree, it'll be a bit harder for it to like create an accurate prediction. Alright, so now we'll just iterate through everything for I in data.drop class access equal to 1 dot wait what should be here. So like the reason why we did it here is wait, is it dot length? Wait, dot columns, yeah. So basically the reason why we did that is so now the column will iterate through all the columns, which is these, beside class, which is basically what the dot drop mean. It means that we'll take out this class column, and access equal to 1. It just means that we will take out class as a column. If access equal to 0, it will just mean rows, which is like this type of stuff. And after we will go through each columns, first we'll give you some variables we need to assign. Alright, that's a spelling error. So then we need to do this. None equal to the length of data columns dot unique -1. So what does this mean? It's basically so data columns, it's just mean we're taking that column, buying for example, and that unique is finding all the unique like variables in that column, such as v high is a unique variable, high is a unique variable, low is a unique value, basic that's a point, and we subtract 1 from it because we start with 0. So if there's 3 unique variable, we have 0, 1/2, and 2/2. So that's why we subtract 1 from it, since value start with 0. And then now we'll just write this step. It's pretty simple, just 1 over num. Since like when you add the step, like every time we iterate through a unique value. All right. So basically, for I in data column, the unique for j in data columns, if j equal to I, then alright, sorry. If j equal to I, then j will then equal to value. J equal to value. Okay, and then otherwise, j will just equal to j, and then, oops, sorry. Wait, let me take a paper towel to sneeze. Yeah, I want to get some tissue since it's kind of cold here. So like, if that caused any inconvenience, I feel really sorry. So let's continue. And then data will plus the data value will be plus equal to step. All right. So this few lines might look kind of confusing, but it's actually quite simple. Basically, so first we'll iterate through. So this is like basically like a loop, and it will iterate through the unique values of that column. For buying as example, it will iterate through v high, mid, and low. Like v very high, and then high, and then mid, and then low. Then it will iterate through all the data. For example, like the data would be short in this example. Be high, mid, high, V high, low, mid, V high. So in the first loop, we are going to iterate through the V high, and then it's a double loop. So we will now iterate through this whole thing. And if it equal to very high, then so like when we look at this, does this equal to V very high? V high? It doesn't. So it will just equal to itself. Does this equal to V high? It doesn't. Does this equal to V high? It doesn't. Does this equal to V high? It do. So now, this will equal to value, which at this point is 0. And then is this? No, this is not. But this is. So this will also equal to 0. And now we're at our second loop, which is high. But this time, value also plus equal to the step, which is 1/3 in this scenario, because there's 4 unique number, and when we subtract 1, that's like 3. So it's 1/3. The step is 1/3. So 1/3 plus 0, that's 1/3. So we're at high. And is this high? Yes, it is. So this will equal to 1/3. And this will also equal to 1/3. And then now we're at mid. And mid, like, but we also need to add the steps. So now mid will equal to 2/3, 2/3, and then 3/3. So that's basically the point of this loop. It will just iterate through everything and assign it its value. What? Oh. I forgot to add the parenthesis. And now we can print out data. But I'm not really sure. Like we modified the data already, but I'm not really sure would this work yet. I actually don't get why. Like we already like modified it, but like it just doesn't really impact the original like data set. I think that's why. Alright, now we already changed the data. And now we're getting into the juicy part of decision tree. So, but first we still have some variables such as x train, x test, y train, y test, which equal to train test split, x, y, and test size equal to 0.1, and then x will equal to data columns, data dot drop in that column class, class, and then y will equal to data class. So this would just like basically x would just be data, be like all the columns of data beside class, because the drop variable. I'm pretty sure we add a parenthesis, and y just only this column, which is class. And this it just like so every model we need a large amount of data to feed to this model, so this model can actually have a precise like those questions that can be asked to find like what we want and what we need. So I don't really get like really very deep into this function. I might explain it in the future. So now we'll call the decision tree. I would just call it model. So model you could decision tree classifier. So this like all we gonna do is modify the data so that this classifier can be able to read and predict upon it. Yeah, that's why like we have all those libraries that can help us, which is made our job very easy. And so the decision tree, no, just a model, model dot fit x train and y train. So this function, in simple term, it just split it the x and y data into a training set and a testing set. So the training set is basically like the data, and the testing set is basically what we want to predict. So it will like try to predict on the X train, and X test will just be the answer. So like a good analogy is that not really that good, but X train will be a test, and X test will be the answer, and our model will be like a really good student that studies like 10,000 tests, and then it will do the test and grade itself. Yeah, and this is basically letting it like study this test. And all right, now we will do something model dot score. I think it's X test and Y test. So that's accuracy equal to this print the accuracy. I think this word class not found in access. Okay, I think data.drop. Why is this wrong? Did I mistype something? Let me see. Data.drop class. So X you could do data.drop. So we don't need. See. Method is not subscriptable. Oh. Wait. Oh, wait. Is it because we forgot to give in the access? Access equal to 1? Is this why? Cannot convert string to float. Wait, what? Let me see. Model.fit X train and Y train. So it's X test. This is kind of weird. Like X train and Y train. Yeah, why is it correct on this one? Is it even correct on this one? Yeah, on this one it is correct. Why is that? So the score doesn't fit. Test size. So it's yeah, it is X like X train and Y train. Huh. Why is this? Wait. I think is it because like wait is it because like in this you can actually see so in this one yeah in this one we modified the data. But did we do the same thing in this one? Let's see. and print X and print Y. Could not. Oh, shoot. So there's something wrong with how we dealt with the data. So wait, let me see. For I in data class, yeah, I don't really think this is. Wait, can we print Y though? Well, let me delete these. Control X, print X, and print Y. Let me see if it works. Oh yeah, we didn't modify the data correctly. Okay, I mean, uh, for I in data columns that unique. Oops. Okay. So let's. I think the error is that's is it because they're like technically the same thing. Oh, it is because of this. All right. So let me see. So for J, for letter, easier for comprehension. Letter you go to I. The letter what you could do. We don't really need the else statement. Does this work? What the hell is this? God damn. So for letter in data columns, this doesn't really work. Like, do we need to write it in this format? I mean, that would be really annoying if we do need to write it in this format. If letter. But where's the error for I in data call? So wait, let me see. So the error is just that if statement. Oh my god. For letter. So then we will iterate through the columns. Wait, let's print column. Computer science. Always shouldn't deal with all of these stuff. Oh, okay. So, wait. So we might actually need to use this statement. So for letters, wait, no. I think we used a triple loop here. So this is just for letters in data columns. Let me see what it print out. Bro, what? Alright, let me print out the letters. Yeah, so it do work, I think. It's a lot of stuff. Let me just go here. It's a high, mid, low. High, mid, low. Yeah, so it iterated through everything. And now we print letter. We only print it if it equal to I, which should be all the data. Wait, I think I know why. Like we got. Wait. Why is it all 1.0? I think this is alright. Yeah, cause so data columns. Data columns. And then so letter doesn't really modify the data itself. So data columns equal to value. But I don't really think this works. Just don't think so. Let me print, and then now let me print X. Like otherwise I actually. Wait, that worked? Okay. Alright, now we need to so it's just that data. Let me see if it actually worked. Column. I don't think so. We have a 61%. Yeah, I think this is wrong. Let me just print X. Yeah, so it's all 0. It's because we made a whole column equal to value. But what we should do. Oh, I see. So now we just need import numpy as pd. I mean no, np. and then array equal to numpy np dot array. So if letter equal to I, then array equal to array plus I. After we did that, what we can do is that we're gonna give it in. So after this, data columns will equal to array. Yeah, I think that would work. And then array will equal to, I think this should work now. Alright, let's go to Google. How to add an element into a NumPy array in Python. Because I actually don't really know NumPy that well. Oh. So, okay. Array dot append I. That's actually kind of easy. No. What? NumPy.nd array. Is it because we need to like import another library or something? Wait, is this even? Oh, it's in NumPy. Bro, what? Let me see. Should be somewhere. Huh? Alright, so it is append. It's np.append. What? Let me see the example. So, oh. So, okay, I see. So array equal to array dot append I, and then array just go to empty array. No, not array dot append, np dot append. Now it should work. What? Can we just give in like -1 since it's the last index? Oh, shoot. Wait, how do we add an element to the end? Okay, I don't really like NumPy now. Alright, we would just create an empty list. I hope that works though. Dot append I, and the array will just equal to empty list again. Does that work? it down. Wait. Data columns equal array. Oh wait. Oh yeah. I mean, I'll just use sentence now because it will be actually really weird. Alright, let me delete this and this. Alright. So this statement is also very simple, but it's basically we put like letter in data columns, and then if letter equal to I, then it will equal to value. Otherwise, letter will just equal to letter. And then I tried to do it in a simpler way, which is like so it will be easier to understand in like a for loop, but like I never realized that, but like eh, since we're assigning this list to the whole column, there's only two ways. Either we find the index, which means I need to rewrite this whole program, or is we create an array and just like assign it to this, which is what I did here. So this is like it might be a bit more complex, but it's the only way to fit this for loop. I'm pretty sure. If you want to make it into like those if statement, I think I'm pretty sure rewrite this whole program like right here. But still, it's basically the same thing as what I did before, but it will do it simultaneously so that it can be assigned to this whole column. And talking about back to this, so model the score this X test and Y test. It basically just means we'll let the model look at X test and Y test. And like since I already did and then we will let it self score and then we will let it and we will see the accuracy which it's the 0.98265895. That basically means they have a really good accuracy. It's 98%. Uh like the accuracy would be higher if there's more data that we give in, and it will be lower that if there's less data we will give in. But I would say that I don't really think there could be any model that can predict like perfectly, since I believe that there will always be an outlier that our data will not include. We can have a 0.9999999, but that like a normal range data will always include outliers. And if you want to include an outlier in a data set, it will like lower the data set's ability to deal with average, like normal data points. But that is alright. Maybe we can solve it mathematically. And now, we need to do this. I will just copy paste the code because I want to speed through this. And after we already see the accuracy, this would be a better way to see the accuracy with data visualization. Predict. Is it X test? Oh wait, I forgot to import Seaborn. Seaborn is also a very good data visualization library. Does it work? Alright, finally. So this, so the basically the answer to X test is Y test, and then we created a confusion matrix, and then it's basically like a heat map, and we will show it. So a heat map is basically like the higher the number, the lighter the color, and so if wait sorry so like this basically just mean what we predicted. So we predicted what we predict is 0, but the actual answer is also 0, and we got 38 of these, which basically mean we got it correct. So the diagonal is where we got it correct, which is like we got 1 and our prediction is 1 and we actually got 1. Our prediction is 2, we got 2. Our prediction is 3 and we got 3. And the rest is the incorrect one. Like what we predicted is 0, but actually the answer is 1. And there's 2 of these. When we predict it's 0, it's actually 2. And there's like 1 of these. And then when we predict it's 2, it's actually 0. We predicted it to be 4, but it's actually we predict it to be 3, but it's actually 4. 3. Wait, what am I talking about? This is the correct one. This one. And so this diagonal just basically means how much we got correct. You can just add it up. And on this, basically is just a scientific notation. How you read it is like this. So this E stands for exponent. So which is 1.2 times the exponent of 0.02, which is just 2. So 1.2 squared, which times 10 squared, which is 1.2 times 100, which is 120. So we got 120 twos, and all of them are actually 2. And I'm pretty sure 0 means unaccepted, and 1 is accepted, 2 is like good, 3 is very good. And thanks for watching. Oh wait, I kind of forgot, but we forgot to do the I call so-called homework. And basically we need to see if how much stores this data like does this column have an impact on our prediction, or like just will people accept it or not. And the hint is that see what will it look like our accuracy without the door. And all right, 5 seconds to just think about it, and then I will review the answer. 5, 4, 3, 2, 1. Okay, so it's actually really simple. We just do like this: x equal to x dot drop doors, and access equal to 1. And this is basically how you do it. Why do I always make this mistake? Okay, so now if we look at the diagram, where are you, diagram? We'll see there's a lot more like errors, I guess. This is not the best way to see it. Print. Remember the accuracy I told you guys? We can use that model square X test. Since with that data visualization, we cannot really get like a percentage out of the total. So let's do it like this. Now we see it's only 94%. But without this, will be 98, basically 99%. And though like that 5% increase might look kind of small, but it actually have a really huge impact on the data prediction. Because if we're using it in medical science, that 5% might be like 5 lives. So yeah, that's basically the end of it. We did a real example. We did some data modification to the CSV. We learned how to do the train test split, how to score yourself, and find the accuracy. And thank you very much. Bye.